Okay, we're down to the last section in Chapter 7, and this section is dealing with solving right triangles. Now, when you solve a right triangle, you're looking for all its side lengths and all of its angle measures. Now, you can use the Pythagorean Theorem or SOHCAHTOA to do this. You can also use inverse trig ratios. Now, inverse trig ratios are used to find the angles inside a right triangle. We used the last two sections, we dealt with sine, cosine, and tangent, helping you set up ratios that showed how an angle related to its sides. If you look at sine, it was the relationship between the opposite side and the hypotenuse. If you look at cosine, you had the adjacent and hypotenuse. Now, when you deal with the inverse trig ratios, you are looking for the angles. We're going to use those same ideas. You know tangent, you know sine, you know cosine. We remember the SOHCAHTOA. Okay? We can use those same ratios, but use the inverse functions to find the angles, and you'll see what I mean here. If, again, we deal with angle A. If you want to find angle A, meaning the measure of angle A, or how many degrees it equals, you can use the inverse sine, inverse cosine, or inverse tangent of angle A to find the actual measure. But here's the thing. Here's where you really have to know your trig ratios. If they give you, let's say, BC as 3, and they give you AC as 4, here's what you have to ask yourself. What parts of the triangle did they give me? If I'm looking for the measure of angle A, what other sides did they give me? Now, if you look at your trig ratios, all of them use either the opposite, the hypotenuse, or the adjacent sides. So what you have to ask yourself is, if I'm looking for the measure of angle A, what do I know? Well, in reference to angle A, you know the opposite side, and you know the adjacent side. Well, you have to ask yourself, what ratio uses the opposite and the adjacent? That's tangent, which means that you would use the inverse tangent to find the measure of angle A. And we can write that like this. The inverse tangent, and if you look directly above the tangent button on your calculator, you'll see the tan -1. That's the inverse tangent. Think of it as going in the opposite direction. The inverse tangent of the opposite over the adjacent will give us the measure of angle A. Okay? Now, we can go through this and we can practice this with the inverse sine, the inverse cosine. Either way, more than likely, if you know how to do sine, cosine, and tangent, you're just hitting a different button to find the measure of an angle as opposed to the ratio. Okay, you've been hitting the sine, cosine, and tangent button so long, now it should be easy just to flip it over and go the inverse sine, inverse cosine, and inverse tangent. Note, SOHCAHTOA is great for finding trig ratios. Once we know the trig ratios, we can use the inverse trig ratios to find the missing angles. And let's go ahead and practice that now. Here you're given two different triangles in example 1. It says use the inverse trig ratios and your calculator to find the measure of angle A and the measure of angle C to the nearest tenth of a degree. Well, there are a couple different ways we can do this. First, we're going to start with angle A. Now, angle A, if we want to find the measure of it, first we have to figure out what we're given. We're given angle A, but we're also given the opposite side. Notice how it's across from it. And the adjacent side. Opposite and adjacent. Well, we just did this problem together. You should know that that is the tangent function. Okay? So watch what I'm going to write. I'm going to write this. The tangent of angle A equals the opposite over the adjacent. Now, the tangent of angle A, which I don't know, that's my variable. I want you to think of this. If this was a multiplication problem, let's say that tangent represented x and A was just, the angle you're dealing with. You'd be multiplying these two together. So how would you undo that problem? Well, you would divide it. Here's the thing, though. You don't want to divide by the tangent, you want to do the inverse tangent. Just like when you have something squared, you don't divide by a square, you do the inverse function. Here we're using tangent. In order to undo the tangent function, we need the inverse tangent. Well, when we take the inverse tangent of our fraction, we get the measure of angle A. So if I punch in the second tan button, I see that on my graphing calculator comes up tan -1, and then it's using parentheses. It wants me to plug in 20 divided by 15. And when I hit enter, I get 53.13, and that's telling me that angle A is 53.13 degrees. There's one little thing. If you did not get 53.13, I want you to hit the mode button, which is directly to the right of your second button. And the third line down will say the words radian and then degrees. Now you want to make sure that the degree is highlighted, not the radian. Radian is dealing with rotations of a circle. We're not looking for circles, we're looking for angles, so we want degree. Use your down arrow and then your over arrow. Make sure that the degree is blinking, and then hit enter, and now it should be bold and blinking. And then you can just hit second quit, and now it's in the right mode. And if you punch in the same thing, tan -1, or the inverse tangent of 20 over 15, and hit enter, you should get 53.13 degrees. We used the inverse tangent function to find the measure of angle A is 53.13 degrees. Now let me ask you this. What can I do to find angle C? Do I need to use a tangent function, or a sine function, or a cosine function? Do I need to make it that hard? And I would say no, and here's why I would say no. There are 3 angles inside of a triangle. I know 2 of them. I know 53.13 and 90. But what do I know about the interior angles of a triangle? They all add up to 180. So what I'm going to do is I'm going to use simple math and say 53.13 plus 90 plus angle C equals 180. Subtract 53 and 90 from both sides, which is the equivalent of subtracting 143.13. And when I subtract 143.13 from both sides, I find that the measure of angle C, whoops, I punched it wrong on my calculator, 180 minus 143.13, I find out that angle C is 36.87 degrees. Now you'll notice for the second angle, I didn't need to use a trig function, but for the first one I did. So hopefully you can see the difference here. Now I'm going to erase this, and for the sake of practice, I'm going to find angle C using trig ratios. Erase all that. Here's angle C. And now what I'm looking for is angle C, measure angle C. Now look at what you're given. You are given the opposite side and the adjacent side. Again, what trig ratio uses opposite and adjacent? Tangent. So you could say the tangent of angle C equals 15 over 20. The only problem is we want to find angle C, so I want to undo this tangent function. How do you undo a function? You do its inverse. So I'm doing the inverse tangent function of 15 over 20, and that equals angle C. When I punch that into my calculator, the second tangent button, 15 divided by 20, my calculator tells me 36.89, or excuse me, 87 degrees. Or 36.9 because we're just rounding to the nearest tenth. Either way, you'll notice that that's the exact same answer that we got a second ago when we just did the interior angle sum theorem, where the interior angles of a triangle add up to 180. What I'd like you to do is I would like you to practice finding angle C and angle A in this second problem. Do that now. Okay, hopefully you had enough time to solve for the measure of angle A and the measure of angle C. Now you can see my work here. I found angle A to be 33.7 degrees and angle C to be 56.3 degrees. If you didn't get this, pay attention and make sure you understand how to solve for the angles in a triangle. If you did get this, good job. You can fast forward to the guided practice and see if you can get those 3 problems correct. But let's take a few minutes and let's make sure that we understand how to solve for these missing angles. The first thing I did was look at angle A. Here's angle A. What am I given? I'm given the opposite side and the adjacent side. Just like the last 2 problems, that opposite over adjacent represents the tangent function. So I know that the tangent of my angle equals the opposite over the adjacent. Notice this, I'm not solving anything here. I'm just writing a statement just like I did 2 sections ago when I first was introduced to tangent. I said the tangent of an angle equals the fraction, opposite over adjacent. But now, because I'm looking for the angle, I need to do the inverse trig function. The inverse tangent of 12 over 18 will give me angle A. Well, I can just plug this step into my calculator and find out that angle A equals 33.7 degrees. Remember, that's rounded to the nearest tenth, and your mode has to be in degrees. The nice thing about the graphing calculators is it saves your format. So if you go to degrees at the beginning of a class, you don't have to switch to degrees every time you do a problem. It stays in degrees. Then the same thing for angle C. I identified that angle C, which is right here, I was given the opposite and the adjacent sides. Well, opposite over adjacent, again, is the tangent function. So I could say that the tangent of angle C equals the opposite over the adjacent. This step, you'll notice, is not solvable. We're not solving this statement. This is what we're using to establish our problem that we can therefore solve. Well, if we're looking for angle C, or we're trying to solve for angle C, we want to do the inverse of this function. The inverse of the tangent function is the inverse tangent function. So the inverse tangent of 18 over 12 gives me angle C. When you punch in your calculator, inverse tan of 18 over 12, you get 56.3 degrees, and that is rounded to the nearest tenth. Now, once you solved angle A, you could have just said 180 minus 90 minus 33.7 gave you angle C. Or if you already solved for angle C first, you could say 180 minus 90 minus 56.3 gives you angle A. Or you can just do the trig functions for both. Either way, understanding that you need to set up this step first. This is paramount because this shows that you really understand your trig ratios. Tangent of an angle is opposite over adjacent. We did that for A and C. Then, because we're solving for the angles, we had to do the inverse function. Just like when we undo an addition problem, we use the inverse of addition, which is subtraction. When we have a multiplication problem and we want to solve it, we use the inverse function or division. Here we have a tangent function, and the inverse tangent, or the inverse of that function, is the inverse tangent function. Hopefully you understand that. And hopefully you understand how to solve for an angle, whether you use the trig ratio and then just the subtraction, or both trig ratios. Either way, if you need to pause the video and look at these 2 examples again, go ahead. Look at it as many times as you need. If you understand what we're doing here, let's go to the next page, and we're going to see 3 more problems in a guided practice page. Now this says solve the right triangle. Round decimal answers to the nearest tenth. What I want you to do here, and we're going to label this as 1, 2, and 3. What we need to do here is when it says solve the right triangle, we need all of the missing sides and all of the missing angles. Let me show you what I mean. In the very first problem, we're given BC and AB, but we're looking for side AC. We're given angle B, but we're looking for angle A and angle C. So you have one side to solve for and 2 angles. Well, the way that you can solve for any side of a right triangle is simple. It's the Pythagorean Theorem. What I want to do first is go through and identify my A, my B, and my C. I'm going to write the Pythagorean Theorem just in case you're a little bit rusty and can't remember it. C squared equals A squared plus B squared, where the C has to be the hypotenuse. Well, if I look in this problem, where is my hypotenuse? In any right triangle, the hypotenuse is across from the 90-degree angle. Here's my 90. That means that the side across from it is the hypotenuse. AC, which conveniently is the side that I'm solving for, is my C. And I'm going to randomly label the other sides A and B. Now I can set up my Pythagorean theorem and solve for it. C squared equals A squared plus B squared. Now if I simplify this, 11 squared is 121. 5 squared is 25. I get C squared to be 146. Now, maybe you need to use the reducing radicals, or maybe you need to review that, the very first video of this chapter. But when we want to find C, not C squared, we know what C squared equals. We want to find just C. We need to do the inverse of this function. Right now we're squaring it. The inverse of that is the square root function. So the inverse of a square is just a number. And now I have the square root of 146. Now this as a decimal, and let me just write it down very quickly. The square root of 146 is 12.1, and that's rounded to the nearest tenth. I don't really want to use this because I need perfect answers. I remember that when you punch in the square root of 146, it doesn't give you a whole number, it gives you a decimal. And you have to round that decimal. And now when we're going to use trig functions to solve for our missing angles, you'll be using a rounded answer, not a perfect answer. This is why we have to be able to reduce radicals. Now I'm going to go to a new page and reduce the square root of 146. And if you want to pause the video and solve this also, just to make sure that you can solve it correctly. In fact, why don't you do that? Why don't you pause the video right now, reduce the radical of 146, or the square root of 146, and see if you can reduce it correctly. Go ahead and pause the video and do that now. Okay. A little surprise to me, this is actually a very, very large number that cannot be reduced. The farthest I got was 2 times 73. 73 is a very large prime number, and so nothing goes into it. Therefore, you can't reduce it any further. So we just get the square root of 146. I'm going to go back to my notes here, and C is going to equal the square root of 146. I'm going to erase this and write in its place the square root of 146. Now you'll notice that that was one of the parts that we had to solve for. I'm going to label this very quickly. AC equals the square root of 146, because that was one of my answers. I had 3 things I need to solve for: AC, angle A, and angle C. There's AC. Now I just need to solve for angle A and angle C. Now angle A is right here. And I could use the hypotenuse in one of the trig ratios. Remember, the trig ratios are SO, CA, TOA. And in reference to angle A, now that I have all 3 sides, I have the opposite, the adjacent, and the hypotenuse, I could use any trig ratio I want. Here's the thing. I don't like the square root of 146. I don't like it because it's a complex number. And I could use it in the calculator, but it's a lot easier just to punch in 5 and 11. I don't know if you heard that bouncy trailer going down the road or not, but that distracted me. Hope it didn't distract you. Notice this, that I'd rather use 5 and 11 because those are perfect numbers, they're whole numbers. I would rather use those in my trig ratios, not the square root of 146. But you can do whatever you want. To find angle A, or the measure of angle A, I'm going to use the opposite and the adjacent sides, which is the tangent function. So I can say the tangent of angle A equals the opposite side of 5 divided by the adjacent side of 11. Well, because I'm trying to solve for angle A, use a different color, angle A, I want to do the inverse of this function. I want to undo it. Well, the opposite, or the inverse, of the tangent function is the inverse tangent. So the inverse tangent of 5 over 11 will give me angle A. When I punch this into my calculator, the inverse tangent of 5 over 11, and round it to the nearest tenth, I get angle A to equal 24.4 degrees. So I've solved for my missing side, I've solved for one of my missing angles, and now I'm going to solve for my other missing angle. Now I'm going to take the faster method and just say that angle C equals 180 degrees minus the angles that I already know. I know the 90-degree angle, and I know the 24.4-degree angle. Remember, the inside of a triangle adds up to 180. So if you take away the angles that you know from 180, what you have left is the unknown angle. Angle C, therefore, is, I'm just going to punch this on my calculator, 180 minus 90 minus 24.4. And I get angle C to be 65.6 degrees. Now, it says solve it. It says solve the right triangle, solve for the missing pieces that you don't know. We didn't know AC. The only way we could solve for it is by using the Pythagorean Theorem. We didn't know angle A or angle C. We had to use some trig ratio to solve for one of those angles. You could have used another trig ratio. You could have used sine or cosine to find angle A. I used tangent, and I told you why already. I don't like the complex number of the square root of 146. I like 5 and 11 because they're perfect whole numbers. And you could have even used the sine or cosine function to find angle C. You'll notice that we just used the interior sum of a triangle theorem, that it all adds up to 180. However you want to do it. Now we're getting to the point in the year where you can solve these by yourself. I'm not going to ask why you solved a certain way, as long as you get the answer correct, and as long as you show me you know how to do a problem. What I'd like you to do now is I would like you to solve for the missing sides and the missing angles in problems 2 and 3. Now you'll notice in number 2, we are missing side EF, and we are missing angle D and angle F. And then in number 3, you'll notice you're missing side GH and side JG. Now, GJ, whatever. Now this one's going to be a little bit more complicated. Number 3 is going to be a little bit tougher because you have to use your trig ratios to solve for a missing side. And we'll go over that here in a second. It's not as hard as it seems. I'll give you a hint. You have to use your trig ratios, and then you have to use proportions. Maybe that'll help you. But then, in number 3, you're also missing angle G. You'll notice, in number 2, you need to give me 3 answers. A missing side and 2 missing angles. Number 3, you have 2 missing sides and 1 missing angle. So what I'd like you to do is pause the video and solve both of those problems right now. And then when you're ready to look at your answers, go ahead and replay the video. Okay, now I know both of those problems took a very long time, so maybe you just solved number 2, or you solved number 2 as far as you could, and then you switched to number 3 and solved number 3 as far as you could. But you'll notice that both of those problems take a lot of work, and yes, they take a lot of time. I can help that by just making your homework problems, or the number of homework problems you have, smaller. Instead of doing 25 problems that take, this long, maybe you do 10 or 12 problems. I can fix that, but what I need you to do is make sure that you're trying on these problems. Yes, they take a while. Yes, they take a little bit of problem solving, but at the same time, you need to try. Let's look at number 2. Now, number 2, we were told to solve for EF, angle D, and angle F, and you'll see that I started off number 2 by writing the Pythagorean Theorem. Now, instead of writing c squared equals a squared plus b squared, you'll notice that I wrote using the side letters. I wrote EF squared plus ED squared equals DF squared. You'll notice that that's the exact same ABC, except that instead of ABC, I just plugged in the sides. Then I went through and substituted everything that I knew. I didn't know EF, so I made that my A. I did know ED was 5.4. I did know DF was 9.2, so I substituted those in. Then the next step. Then I squared 5.4 and squared 9.2. Then I subtracted 29.2 from both sides and found out that EF squared, or A squared, is 55.4. Then, to solve that problem, I did the square root. Now, you'll notice here that the square root of 55.4, if you use your calculator, it ends up being 7.443117626. We rounded to the nearest tenth. That's going to come back and bite us, and you'll see why. So EF ended up being either the square root of 55.4 or 7.4. By the way, you don't want to try and simplify this radical because it's a decimal. Whole numbered radicals you can try and simplify. Decimal radicals, leave alone. They're very, very complicated. Then to solve for angle D, which is right here, I used the sine function. And the reason I used the sine function is because I like mixing it up. We've done the tangent problem the last 4 or 5 times. We might as well use sine or cosine. So I used the opposite over the hypotenuse. So I used 7.4 divided by 9.2. Now, in order to find angle D, I needed to use the inverse sine function. Maybe you used cosine, maybe you used tangent, whatever you used, make sure that you're using the inverse functions. My inverse sine used 7.4 over 9.2. When I punched that in my calculator, I got angle D to be 53.5 degrees. Then, to find angle F, which is right here, I did the exact same thing. I used the sine function, which the sine of angle F is 5.4 divided by 9.2, opposite over hypotenuse. To find angle F, you need the inverse function, so the inverse sine of 5.4 over 9.2. Again, maybe you used cosine or tangent, whatever. As long as you understand to look for your angle, you use the inverse functions. Okay? And so, the inverse sine of 5.4 over 9.2 is 35.9. Here is a very, very important, muy importante, a little note. Do both of these added together plus the 90-degree angle equal 180? And the answer is no, they do not. And the reason they don't is because up here at the top, when we didn't use the square root of 55.4 on our triangle, when we used the decimal answer of 7.4, we had to round that. Well, then when we use the rounded answer in a problem, right here, we get a rounded error. Now what that means is we were using an approximate number or an approximate answer in a new problem. Well, that's the approximate of an approximate, which means we get round error. If you said, well, 180 minus 53.5 equals, it'd be 36.5, well, you'll notice that's off by 0.6. That's quite a lot. In fact, on a quiz or a test, or even the final at the end of the year, I give you a rounding error of about 0.5. This problem, we were off by 0.6. You have to make sure that your answers are very, very close. Now, on a quiz or a test, they're built in a better way so that the rounding error, even with rounding error, you're only off by like 0.3 or 0.4. But make sure that you're very careful with that. Notice that problem, how they did not add up to 180 degrees when you add them together, which means something went wrong. That something was just the rounding error. Okay, but hopefully you see how I solved for our missing pieces, or how I solved for our right triangle. Then let's go to number 3. And number 3 was not nearly as simple. To solve for angle G wasn't that bad. You said angle G plus angle H plus angle J equals 180 degrees. Okay, that's just the triangle sum theorem, saying that the 3 interior angles add up to 180. Then I substituted. I knew angle H was 90 degrees. I knew angle J was 53.2. Then when you combine 90 and 53.2, you get 143.2. When you subtract that from 180, you find angle G to be 36.8 degrees. Now that's not hard. Here's the hard part. If you look at this triangle very carefully, and let me erase everything so you can see it really well, you'll notice the only things you are given are angle J and side HJ. Well, now I ask you this. In reference to angle J, because that's the only angle you're given, what side is HJ? Is it the opposite, adjacent, or hypotenuse? And the answer is the adjacent. Well, if I come back up here to my trig ratios, what are the only 2 trig functions that deal with the adjacent side? The answer is the cosine function and the tangent function. You'll notice that's what I used with angle J. I was given angle J, so I have to use angle J to solve for the other angles. But because I was only given the adjacent side, I needed to use that also. I needed angle J because that was the only one I was given, and I needed HJ because that was the adjacent side. Now I want you to watch this. In the cosine function, you are using the adjacent and the hypotenuse. Well, you didn't know the hypotenuse. That's side GJ, which means that when you solve the cosine of angle J, you can set it up as JH over GJ. Okay? Now look at this ratio. There's nothing hard about this. Let me highlight it so you can see. All this is saying is the cosine of an angle equals the opposite over the adjacent, the adjacent over the hypotenuse. The cosine of angle J equals the adjacent side divided by the hypotenuse. Now I know what angle J is. It's 53.2. And I know what JH is. It's 14. Notice how I set this up. Cosine of 53.2 equals 14 over GJ. All I did was substitute there. The very next step, and I told you this at the beginning before we even solved these problems, you'll notice I set this up as a proportion. Now the cosine of 53.2 I actually solved, and it's 0.5990. 5990. And then I put a 1 under it and set it equal to my other ratio. Now I have a proportion, and all of you know how to solve proportions. We cross multiply. When I cross multiply this, you'll notice that I kind of ran out of room, so I'm going to go to another page. Whoops. I get 0.5990 over 1 equals 14 over GJ. When I cross multiply this, I get GJ times 0.5990 equals 14 times 1, which is just 14. Then I'm going to solve for GJ by doing the inverse of this function. This is a multiplication, so I'm going to do the inverse, which is division. 0.5990, divide both sides. When I do that, these cancel out, and I'm left with GJ equals 14 divided by 0.5990. And I find GJ to be 23.4 rounded to the nearest tenth. 23.4 rounded to the nearest tenth. Here's the thing. You could have used the Pythagorean Theorem to solve for the other missing side, but you'll notice that to really show you how to set these up, I used the tangent function. Why? Because GH is the opposite side of angle J. Well, what is the only trig function that uses the adjacent side, which we're given, and uses the opposite side, which is what we want to solve for? That's the tangent function. That's why I use the tangent function here. Just like the cosine function, I was given the adjacent. I wanted to solve for the hypotenuse, so I had to use cosine because it uses both the adjacent and hypotenuse. Now the tangent function, I'm trying to solve for the opposite side, but I'm given the adjacent side. Opposite and adjacent, that's tangent. So again, I wrote the tangent of angle J equals GH over HG, or HJ, excuse me. GH over JH. Then I substituted angle J in, which is 53.2, and I substituted JH in, which is 14. Didn't change anything. My ratio is still the same. All I did was just substitute numbers in. Then I actually solved for the tangent of 53.2. You can plug in your calculator tan of 53.2, hit enter, and you'll get 1.337. Well, now I have a proportion, and I can solve proportions by cross multiplying. When I cross multiply GH times 1, I find GH equals 1.337 times 14 ends up being 18.7. Now that's rounded to the nearest tenth. So you can see how I solve for GH and GJ. Very, very differently than the way we've been solving for problems. In fact, you might even want to rewind this video and do this problem again, or number 2 again. Number 3 was a little bit more complicated because it used proportions in trig ratios, which is something we have not done yet. But that's fine. You already know how to solve proportions, and you know how to do trig ratios. Most of you are pretty good. So when you combine both, it shouldn't be anything overly complicated. We used a proportion to solve our trig ratio in both of these examples. So what I'd like you to do now is let's take a look at our homework. But if you need more practice, I encourage you to rewind this video, try and solve number 2 and 3 again, and then just watch the video to see if you got it correct. But let's take a look at our homework now.